we're moving on to our second to last lesson with Unit 5, and that's parallel and perpendicular lines. Your learning target today, all you're going to be able to do is identify parallel lines. That's it. So today I'm just breaking it down. Can you tell if two lines are going to be parallel or not? Parallel lines never intersect. You know, like train tracks are parallel, they'll never intersect. Okay? But they're not the same train track. A train track can come into that one and intersect, but they're not the same track. Okay? So parallel lines never intersect. They rise or decrease at the same rate. Because if they never intersect, that means they're going the same pace or rate. Rate for a line means slope. A rate is slope. Your rate of increase, your rate of decrease. How is your y changing? So on your graph, I want you to graph the two lines, and they're nice, easy lines. So this one, I have a y-intercept of -1 and a slope of 1 over 1. Remember, if there's nothing there, it's 1 over 1. So from, -1, I go up 1 over 1. So up 1 over, up, over, up, over. There's that line. Now my next one, I have a y-intercept of 2 in the same slope, 1 over 1. Okay, so y-intercept of 2, a dot at 2, up 1, over 1, up, over, up, over. Do those two lines look parallel to you? What is their slope? Same or different?
Same.
So they have the same slope. Notice here, their slope is the same and they are parallel. They will never all of a sudden, according to a line, this is not all of a sudden going to scoot down. It's always going to be the same rate or same slope. Okay? All right, next. Now remember, yesterday I said you have to be a master at getting y alone. Because you don't know slope unless y is by itself. It's not whatever's in front of x. It's only whatever's in front of x when y is alone. So parallel lines, you want to make sure that y is alone first. You could maybe put that in quotations, y alone. When I say y equals mx plus b, it just means get y by itself. And parallel lines have the same slope. Same slope, different y-intercept. Perhaps a visual might be in order. I'm going to try to make some same slopes. Here's a slope. Here's a parallel slope. Another parallel slope. Notice their slopes are the same, but their y-intercepts are all different. Because if their y-intercepts were the same, it would just be the same line. Okay, that's what I mean. So you can't say that these two lines are parallel, they're the same thing. All right, so remember, your target, identify parallel lines. Compare slopes, that's all you do. If the slopes are the same, they're parallel. If they're not, they're not. So I want to know which lines here are parallel. Same slope. Which lines have the same slope? So my technique, I just look. There, notice y is alone all the time here. So all I have to do is just analyze. I have a slope of 3. Any other slopes of 3, Rach? This one, 3x plus 2. So these two lines are parallel. So 3x minus 2 and 3x plus 2 are parallel. What about 2/3? Do I have any 2/3 slopes? So 2/3 x plus 1 2/3 x minus 1. Again, I'm just comparing slope. Not a negative, because negative would intersect. I'd have one that's going up and then one that's going down. Those would be intersecting lines. 4, do I have any slopes of 4? No. Nope. Nope. Done. So these are parallel. Perhaps you want to be able to know how you know it's because their slopes are the same. Do you feel like you understand if they're parallel, same slope? The hard part is when you have to apply it and get y alone. Okay. Next one. Maybe. Now. All right, last part of today. To identify even more if two lines are parallel, you need to get them in slope-intercept form first. Again, y alone. So I cannot judge if they're parallel if y is not alone on both. So I want to know, is 3x plus 2y equals 4 parallel to y equals negative 2/3 x plus 3? So I want to know, are these two lines parallel? Well, let me check. This one, y is already alone, so I'm going to go ahead and just box off my slope. Y is already by itself. This one, I have to get y alone. So how do you move 3x? Subtract 3x, subtract 3x. 2y equals negative 3x plus 4. Divide by 2. Y equals negative 3/2x plus 2. Box off my slope. Are they the same or different? Different. So not parallel. So you have to use your algebra to get y alone. How about these next two lines? Are they parallel? Is y alone on any of them? No. So what I typically did when I was doing this, I'm like, okay, I'm going to have to get y alone on both. And then compare slope. So I'm going to add 2x. (3y) equals 2x plus 4. That's a 4. Nope, because that's minus 2x. Divide by 3. Y equals 2/3x plus 4/3. Who cares that it's a fraction? Don't stop. You're not graphing this, you're only comparing slope, so you don't have to care. You only care about the slope. So my slope is 2/3. Now I'm going to check my next one. I got to move my 2x by minusing 2x. 3y equals negative 2x minus 1. Move my 3. Okay, again, fraction, who cares? Don't care about it. All you're doing is comparing slopes. So y equals negative 2/3x minus 1/3. Box off the slope. Are they the same or different? So not parallel. Oh man, last one. have to get y alone on both. So subtract 4x. You get negative 2y equals negative 4x minus 2. Divide by negative 2. Getting a little tricky with these negatives now. Okay, y equals positive 2x plus 1. Why did I turn it to plus? Because I have the 2 minuses there. This turned to positive because I have the 2 minuses. That's my slope. Next one's way easier. All I have to do is subtract 3x and y equals negative 3x plus 3. I don't think I meant for this to happen, but are these parallel? No, they are not the same. Trust that I probably meant for something to be parallel and then I messed up. So, your learning target today, identify if two lines are parallel. How you do that, compare the slopes. That's it.